On this slide, we're covering three key concepts: CVE, CVSS, and CPE. First, CVE, or Common Vulnerabilities and Exposures, is a standardized identifier for security vulnerabilities. Managed by MITRE, each CVE gets a unique CVID formatted as CVEYYNNN, where YYY represents the year and NNN is a sequential number. Next, we have the CVSS, or Common Vulnerability Scoring System, which measures the severity of vulnerabilities. Scores range from 0, indicating no severity, to 10.0, indicating the highest severity. This system is maintained by FIRST, or the Forum of Incident Response and Security Teams. Lastly, the CPE, or Common Platform Enumeration, is a standard naming scheme used for the identification of hardware, operating systems, and applications. This enables a consistent method for naming and categorizing platforms across various systems and databases. Now, let's delve into what CVE, or Common Vulnerabilities and Exposures, actually entails. CVE provides a standardized identifier for vulnerabilities, making it easier to organize and prioritize these vulnerabilities across different databases and systems. This standardization is crucial for ensuring consistency and ease of reference. CVE information is composed of several key components. 1. This is the unique identifier for each vulnerability, formatted as CVEYYYNNN. For example, CVE 2024-2345. 2. Description. This element provides a brief summary of the vulnerability, outlining the core issue in a concise manner. 3. References. These are URLs that link to more detailed information about the vulnerability, usually providing further technical details and potential fixes. 4. Assigning CNA, the entity, known as a CNA, CVE Numbering Authority, that assigned the specific CVE identifier. To be included in the CVE list, a vulnerability must meet certain criteria. It must be acknowledged by the software vendor. The issue must be independent and fixable. It should have a proven security impact, demonstrating its significance to warrant inclusion. By understanding these components and criteria, you can better assess and manage security vulnerabilities within your systems.
In this slide, we're focusing on how to effectively use CVE data to manage vulnerabilities. For instance, take the CVE example, CVE 2024-2345, which describes a SQL injection vulnerability in the XYZ product that allows attackers to execute arbitrary SQL commands. This unique identifier helps quickly reference a specific security issue. Best practices for utilizing CVE data include regularly checking for CVEs that might affect your software. This proactive approach helps in timely identification and mitigation of potential threats. Tools like the National Vulnerability Database, NVD, are instrumental for this purpose. You can use a simple command like curldex get htsservices.nvd.nv.gov/json CVEs 1.0 keyword, which is your keyword, to fetch relevant CVE data. Additionally, for more specialized database queries, you might use commands such as nv2db CVE 2024-2345 to pull detailed information about a specific CVE. By integrating these practices into your security routine, you can significantly strengthen your vulnerability management process.
On this slide, we are introduced to the Common Vulnerability Scoring System, or CVSS. The primary purpose of CVSS is to provide a standardized way to measure the severity of security vulnerabilities. This standardization helps organizations prioritize their response efforts based on the severity score, which ranges from 0 to 10.0. CVSS v3.1 includes two main sets of metrics: exploitability metrics and impact metrics. Exploitability metrics investigate how easily a vulnerability can be exploited. They include attack vector. This indicates the path or means by which an attacker can exploit the vulnerability. Attack complexity. This assesses the complexity of the attack required to exploit the vulnerability. Privileges required. This measures the level of privileges an attacker needs to exploit the vulnerability. User interaction. This indicates whether or not user interaction is needed for an attack to be successful. On the other hand, impact metrics evaluate the consequence of a successful exploit on the targeted system. They include confidentiality, the impact on the confidentiality of the information resources; integrity, the impact on the integrity of the system; availability, the effect on the availability of the impacted component. Understanding these metrics aids in comprehensively evaluating the risk posed by a vulnerability, allowing for informed decision-making when it comes to addressing such security issues.
The current slide focuses on how to calculate CVSS scores, providing a practical example to understand the scoring system better. The slide distinguishes between different attack vectors, such as network, adjacent, local, and physical, each with a corresponding numerical value that reflects the level of threat. For instance, a network attack vector has a value of 0.85, indicating a high potential for exploitation. We then look at a CVSS v3.1 vector string, exemplified as AVNALUNSUH. This string breaks down how different factors contribute to the overall base score, which is then calculated to determine the severity of the vulnerability. In this example, the base score is 9.8, categorized as critical, signifying a highly severe vulnerability needing immediate attention. The higher the base score, the more critical the vulnerability, helping security teams prioritize their responses effectively.
Now let's take a closer look at the CVSS metrics. The CVSS, or Common Vulnerability Scoring System, uses various metrics to evaluate the severity of a vulnerability. First, we have the exploitability metrics. This includes 1. Attack vector E. This metric assesses the proximity of the attacker to the vulnerable system. It is categorized into network, adjacent network, local, and physical. 2. Attack complexity AC. It measures how simple or difficult it is to exploit the vulnerability, with values of low or high. 3. Privileges required (PAR). This indicates the level of privileges an attacker needs to exploit a vulnerability, ranging from none, low, to high. 4. User interaction (UI). This evaluates whether user interaction is necessary for the exploit. The options are none or required. Next, we have the impact metrics. 1. Confidentiality (C). This measures the potential loss of data privacy and is classified as high, low, or none. 2. Integrity (I). This assesses the degree to which data can be modified, with categories of high, low, or none. A. This evaluates the potential disruption to service availability, again classified as high, low, or none. For practical understanding, a command example is provided. CVS calc v3 aval uin uiaah. This vector string corresponds to a vulnerability that is exploitable over a network, has a low complexity, requires no privileges, no user interaction, is unchanged for scope, and has high impacts on confidentiality, integrity, and availability. These metrics allow us to accurately assess and prioritize vulnerabilities based on their exploitability and potential impact. Let's delve into the concept of Common Platform Enumeration, or CPE. CPE is a standardized method used for describing product names and versions in a consistent format. This standard is crucial because it allows for the precise identification of affected products in Common Vulnerabilities and Exposures (CVE) records. The format of a CPE is structured as follows: CPE/part, product, version, update, edition, language. This structure ensures that every part of the product's identity is captured accurately, from the vendor's name to the specific version and even the language if applicable. For instance, consider the example for Adobe Flash Player, which is represented as CPE at Adobe Flash Player 32.ado.114. Here, A stands for application, followed by the vendor Adobe, the product Flash Player, and the version 32.0.114. Another example is Windows 10, denoted as CPE/Microsoft Windows 10 x64, where O stands for the operating system. By adhering to this format, security researchers and IT professionals can match specific products to known vulnerabilities efficiently, enhancing the overall security posture of an organization. Now, let's discuss the practical application of CPE using tools and commands. One of the critical aspects of utilizing CPE is leveraging tools like the NVD, National Vulnerability Database, and CVSS, Common Vulnerability Scoring System, calculators. For example, use a simple command with curl to fetch specific CVE details from the NVD API, curl-x get, that's nvd.nist.gov/json CVET in 2024-12345. This command retrieves detailed information about a particular CVE, which can then be analyzed for its impact on your system. When it comes to matching a product to a known vulnerability using CPE entries, consider the following example: CPE/A example product 1.0. This CPE string can help identify whether the specific version of your product is affected by any listed vulnerabilities. For deeper analysis, tools like NVD2DB can be employed. Running this tool with a CV identifier such as NVD2DB CVE 24-12345 allows for an in-depth examination of the vulnerability data and helps streamline the vulnerability management process. These tools aid in the automation of vulnerability assessment and management, ensuring your systems are better protected and compliant. In conclusion, let's recap the key points we've discussed in this course. The Common Vulnerabilities and Exposures CVE system provides unique identifiers for security vulnerabilities, ensuring there's a consistent reference across various tools and platforms. The Common Vulnerability Scoring System, CVSS, offers standardized scoring, which helps in evaluating the severity of vulnerabilities, making it easier to prioritize actions. The Common Platform Enumeration, CPE, is crucial for the standardized naming and identification of IT products. We recommend conducting regular vulnerability scans and consistently monitoring your systems for any new security issues. Use CVSS scores to prioritize which vulnerabilities should be addressed first based on their severity. Integrating CPE into your asset management practices can greatly improve your tracking and identification of affected systems. As the next steps, consider implementing automated tools that handle CVE, CVSS, and CPE workflows to enhance your security management processes. Additionally, it's vital to stay informed about the latest vulnerability disclosures by following resources such as the National Vulnerability Database, NVD, and other relevant sources. This proactive approach will help maintain robust security within your organizational infrastructure. On this slide, we've provided a list of valuable references that will serve as essential resources for deepening your understanding of CVE, CVSS, and CPE. The CVE MITRE website is pivotal for obtaining unique identification for vulnerabilities. The National Vulnerability Database is your go-to for standardized vulnerability information and updates. First is where you'll find detailed information on CVSS scoring, which will help in assessing the severity of vulnerabilities. IBM's documentation provides comprehensive guidance on leveraging CVE, CVSS, and CPE in your security workflows. Lastly, the MITRE CPE dictionary is essential for standard naming conventions in IT products, facilitating better asset management and tracking. Thank you. Did you enjoy the content? If so, please leave a like to show your support. Don't forget to comment below with any thoughts or questions you might have. Your feedback is invaluable and helps us improve. Also, make sure to subscribe to the channel for more informative content. And if you found this information useful, share it with your friends and colleagues. Thank you once again for being a part of this learning journey.